In this video, we are going to define power, state its several units, and use the rule of power to solve problems. Power is defined as the rate at which work is done, or it is the rate at which energy is transferred. Whenever something is the rate at which anything is done, or rate of change of something, that means that quantity must be divided with time. So I can write my expression for power as rate at which work is done. That means work divided by the time. If this time interval is very small, we can rewrite the expression for power as dW over dt. So this is the basic definition of power and the basic rule of power that we use for problem solving. The SI unit of power is watt, which we write as capital W. Now do not confuse the SI unit of power with the notation of work. The symbol of work is also capital W, whereas the unit watt is also written as capital W. Do not confuse these two. You must remember that whenever I have an expression, let's say power P equals 100 watt. Unit is a quantity that is written after the number in your expression. So this term over here is my unit, which comes after the number. So if you have W after the number, that is the unit, which is watt. And if you have an expression written as W equals 10 joule, anything that comes before the number, that quantity is the symbol of the physical quantity. So W before the number is the symbol of work. So use this idea to differentiate between the two W. If it is after the number, it's a unit and the unit is watt. If it is before the number, that means it is a symbol and the symbol W represents work. 1 watt can also be written as 1 joule over 1 second. Because power is defined as work done over time, unit of work is joule and unit of time is seconds, which you can also rewrite as 1 joule I can write as 1 kilogram meter squared per second squared over 1 second. And when you solve this, you can rewrite the expression watt as 1 kg meter squared per second cube. So these are the three different ways in which you can express the unit of power. First one is watt. Then a watt can be written as 1 joule over 1 second. And in kilogram meter second, it can be written as kg meter squared over second cube. Exam can ask you to identify the units of power. Maybe they can give you any one of the unit and they will ask you to identify which one of these is the correct unit of power or which one of these is not the correct unit of power. So you must learn how to derive them from one another, or you must memorize all of these units. Another important unit of energy is joule. And I can rewrite this expression here for joule as 1 joule equals 1 watt times seconds. If you want to write a commercial unit of energy, that commercial unit of energy is kilowatt hour. This is the commercial unit of energy. It's not the unit of power, it's unit of energy. And how do we relate kilowatt hour with joule? 1 kilowatt hour is equivalent to kilo means multiply 1000 watt, 1 kilowatt is equivalent to 1000 watt. Every hour has 3600 seconds. So 1 kilowatt hour is basically equal to 3.6 times 10 to the power 6 joule. Or I can also write this to be equal to 3.6 megajoule, where mega is a prefix which has a multiplier of 10 to the power 6. So in exam, they can ask you conversion from kilowatt hour to joule. And if you want to convert from kilowatt hour to joule, you multiply with this number 3.6 times 10 to the power 6. And if you want to do the opposite, if you want to go from joule to kilowatt hour, you will divide by the same number. Another popular unit of power is horsepower. Horsepower and foot-pound per second. Now, how are these two related with the SI unit of power? 1 horsepower is equivalent to 746 watt, or it is equivalent to 550 foot-pound per second. So this is the relationship between horsepower, watt, and foot-pound per second. In your exam, they can ask you any one of the important unit, and you should know the conversion between them. Sometimes they will give you the power in watt and ask you to convert in horsepower, or maybe the question will give you the power in horsepower and you will have to convert that to watt. So remember important units of power. First one is the SI unit, which is watt. This watt you can also write as joule per second, which is also equal to kilogram meter square per second cube. And the other two popular unit of power is horsepower and foot-pound per second. Then one important unit of energy is kilowatt hour. You must remember the relationship between kilowatt hour and joule. 1 kilowatt hour is 3.6 times 10 to the power 6 joule. Now let's use the rule of power to solve a problem. Solve problem 6.1. Power produced by Niagara Falls. Question says, a Niagara River delivers an average of 5520 meter cube of water per second to the top of Niagara Falls, where it drops 49.0 meter. If all the potential energy of that water could be converted to electrical energy, how much electrical power could Niagara Falls generate? Let's write down what the question has given. Question has given me an average of 5520 meter cube of water per second. Now meter cube is a unit of volume. Per second means per time. So this number over here, 5520, that is my volume per unit time. I will write that as volume V over time T equals 5520 meter cube per seconds. Then they have given me the height from which the water falls. So height h will be 49.0 meter. If all of the potential energy of the water is converted to electrical energy, how much electrical power could the Niagara Falls generate? So I need to calculate what is the power P. Let's use the rule for power. Power P is equal to work done over time. This work done is equal to the potential energy of the water, which is mgh over time t. Question has not given me the value of mass. I don't know what is the mass of the water. But they have given me a relationship in volume. So I can relate volume with the mass of a quantity to substitute for m here. Now, what is the relationship between mass and volume? We know that density rho is equal to mass over volume. This expression is called rho, which represents density. So density is equal to mass over volume. I can rearrange this term to write mass as density times volume. When you rearrange this, you move volume to the top and multiply it with density to get the mass. So this is the expression of mass which I can substitute here. I will rewrite my power B as, in place of mass, I will write rho times V into G into H over T. In my expression for power here, I know what is V over T. So let me write them separately. V over T into rho into G into H. Because V over T is given to me in the question. What is the density of water? Density of water is a constant which is 1000 kilogram per meter cube. And this constant must be given to you in the question. So I will use this constant in my rule here. Let's substitute. V over T is 5520. Density is 1000. G is 9.81. And the height is 49.0. And when you solve this, you get your power output as 2.65 times 10 to the power 9 watt. 10 to the power 9 I can write as giga, capital G. Capital G is called giga. That has a multiplier of 10 to the power 9. And I can rewrite my power as 2.65 gigawatt. So when you are solving for power, not always will they give you the value of work. Sometimes you may have to use work kinetic energy theorem or work done by a force or the relationship between work and potential energy to calculate W. And even when you find the value of W, not always will they give you the value of M or even the value of T. You will have to use your basic information about mass, density, and volume and whatever is given in the question to arrive at an expression that you can use to solve the problem.